Hi everyone, in this video we're going to sketch the graph of y equals 2 sine 3x plus 1. So this graph is a vertical translation or has a vertical translation. So you can see here the plus 1. And other bits of information that are important is we've got an amplitude of 2 and the 3 is our value of n, which kind of tells us what our period is going to be. All right, so let's write that down. So an amplitude is 2. Our period, so remember for sine and cosine graphs, it's 2 pi on n. So for this one, it's 2 pi on 3. And we've shifted up 1. Now, this vertical translation does change our range. So our range was initially from -2 to 2, because that's our amplitude. But because we've gone up 1, basically, and I'll do this in a different color just so we can see, plus 1. Plus 1, and I've just noticed that's a curved bracket, not a squared bracket, so let's just make sure we square that off. So that's going to be from -2 plus 1 is -1, and 2 plus 1 is 3. So just make sure you do take note, if you've got a vertical translation, that your range does change. Now, when we're sketching, let me see if I can make this a little bit smaller so we can see everything in one go. All right, when we're sketching, remember we need the 5 points, so usually 0 being one of them, and we use the period to do that. So we're going to sketch this, we're just going to do one full period. So let me just do, I don't know, let's go every 4, 1, 4, 1, 2, 3, 4, 1, 2, 3, 4. Now, it doesn't matter what you have in between. I probably wouldn't put it right at the end, because if we wanted to go all the way to pi, it would mean that we could actually, no, I'll keep it like that. Sorry, I'm thinking as I'm doing it. So 2 pi on 3. Now, if you had to put the rest of the scale on, half of 2 pi on 3 is pi on 3. And then half of pi on 3 is pi on 6. And then halfway between pi on 3 and 2 pi on 3 is pi on 2. Now, let's say you didn't know that. Basically, all you're doing is your scale is going up by pi on 6. So we've got pi on 6. Pi on 3 is the same as 2 pi on 6. Pi on 2 is the same as 3 pi on 6. And 2 pi on 3 is the same as 4 pi on 6. So you can change your denominator if you wanted to and just make them all the same. It's a little bit easier to do your fractions. All right, so I'm keeping that one. I know this isn't the first one where we've had a period of 2 pi on 3, so hopefully you're okay with that. All right, so now usually with our amplitude, we would go, all right, there's 2 and there's -2. But because we've shifted up 1, we're now going from 3 down to -1. And instead of your, oh, Lucy's, I think, no, what are you doing? Okay, sorry, I thought my dog was going to rush out and probably bark at some cats. All right, so your halfway line is usually your x-axis, but now it's shifted up to y equals 1. So I'm just going to draw a dotted line there. So that's at y equals 1. All right, these aren't as hard to draw as graphs with a horizontal translation. But you do got to keep in mind, you can do the translation, you can draw the graph without the translation and then do the translation, but it's kind of unnecessary. So if you feel like that would help you, so drawing, say, 2 sine 3x and then shifting it up 1, you can do that, but you kind of don't need to. But you do need this green dotted line, so the halfway line. All right, so it's a sine graph, so we're starting at 1. So remember, we'd usually start a sine graph at 0, but we're shifted up 1, so we're going to go up to 1, and then pi on 6 is up here, then pi on 3, and then down pi on 2, and then back up at 2 pi on 3. So then we just join our dots. Oh, I'm loving this pink. Sorry. There we go. Now, if we had to stop at, we had to go all the way to pi. So here would be 3 pi on 3, so just pi. you can easily draw that. We don't have to do the end point like we did in the previous video. I can't remember whether what our domain was actually for this one. And I think I did pink on this one. All right, and if you wanted to go in the other direction, all right, again, just repeating basically. 1, 2, 3, 4. 1, 2, 3, 4. All right, and you get the gist. So we're going to go down this time as far as -1. And then we're going to go here. So remember your dotted line, I haven't got it on this side. I've chosen the wrong pen. Chose the thinner one. It's all good. All right, so there you go. So we're basically going from -pi to pi. Now, if you needed to know your x-intercepts, so you should really do your x-intercepts. Where are we? Let me do the highlighter. So this point here, this point here, this point here, and this point here. You could just let this equation equal 0 and then solve for 0. All right, so you just have to rearrange it. Now, because we haven't done solving equations yet, so we're doing the graphing and then we're going to do the solving, we can just leave it for now. But if you wanted to go ahead and do it, it's not actually that hard because you should know your exact values. This one turns into an easy one with exact values, but we'll leave just the x-intercepts for now until we do solving equations. Okay.